Question 9. This question is about different pH values. For pure water at 40 degrees Celsius, pH equals 6.67. Student thought that the water was acidic. Explain why the student was incorrect. Well, same thing I said last video. If it's talking about water, acidic, and why is it not correct? It's because H plus is equal to OH minus. And what this equation implies, that water is neutral. So if water is neutral, it can't be acidic. Therefore, she was incorrect. And then the second part, determine value of Kw at this temperature. Kw is equal to H plus OH minus. However, in this question, we have nothing about OH minus. Not one piece of information. So what we're going to use instead is we're going to use Kw, assuming that, and it becomes H plus squared, which is perfectly acceptable. And we know pH equals 6.67. Well, we know H plus equals 10 to the power minus pH, which is equal to 10 to the power of minus 6.67. And that will give us a H plus value, 10 to the power minus 6.67. 2.14 times by 10 to the power of minus 7. And therefore Kw is just going to be this squared. H plus, which we just worked out, squared. So I'm just going to do brackets, answer squared, and we get 4.57 times by 10 to the power of minus 14. 4.57 times by 10 to the power of minus 14. And it doesn't say any single figures, so that should be fine. 9.2. Sodium hydroxide solution was added gradually from a burette to 25 centimeters cubed of 0.080 mole per dm minus cube of propanoic acid at 25 degrees Celsius. The pH was measured and recorded at regular intervals. The results are shown in figure 4. Okay. Use figure 4 to determine the value of Ka. Well, we know Ka, first things first, Ka, what is Ka? Ka is H plus. It's just recalling your equation that you do need to know off by heart. I'm pretty sure, yeah, there's no such thing as a chemistry form in the booklet. I'm pretty sure there isn't. H plus A minus over HA. Right? Well, what is the pH of the acid on its own? Well, that is when the volume is 0. When the volume is 0, the pH is equal to 3. So we know the pH is equal to 3. We want to find out the Ka. Well, the Ka is going to be H plus A minus over HA. Yes, but the same thing we did in 9.1 is we manipulated it to get H plus squared. Same thing here. We can rewrite it as Ka, or use the other equation, Ka is equal to H plus squared over HA. Well, Iman, how do you find H plus squared and HA? Perfect question. Well, we're going to use the same equation as 9.1. H plus is equal to 10 to the power minus pH. And we know pH is equal to 3. So it's just therefore it's going to be 10 to the power minus 3. It's going to be Ka equals 10 to the power minus 3 squared divided by HA. And in the question it says 225 from a burette to 25 centimeters cubed of this much of the propanoic acid. There we go, that's the concentration of the acid. That's all we needed. 0.080. So we do 10 to the power minus 3 squared divided by 0.080, which is equal to 1.25 times by 10 to the power minus 5. And you can see how, repetitive these questions are. In 9.1, they wanted us to find out the value of h plus, and we used h plus is equal to 10 to the power minus ph. 9.2, exactly the same equation, h plus equals 10 to the power minus ph. So a part of answering the Ka and Kw questions, and same with Kp and Kc, but because Ka and Kw is year 13, and it probably, is harder than Kc and Kp, just learn the equations and do a bunch of practice questions, and you should get the hang of it. So we get that. And 9.3, suggest which indicator is the most appropriate for the reaction. Question 9.2. Well, what is the pH? The pH is 3. So, which is the most appropriate for the reaction? Question 9.2. So we've got 3.1 to 4.4. Definitely no, because that would be what? 3.1 to 4.4 is something here. We've got 6.0 to 7.6, again no. 8.2 to 9.8, yeah, that's fine. That is probably most appropriate. And 11.6 to 13.0, well, no, that's not going to be correct. So the answer is cresol-phthalene. That's how you spell it. Question 9.4. Student prepared a buffer solution by adding this much of a salt to 100 centimeters cubed of a solution of a weak acid. Before I even attempt this question, let's construct the Ka equation. Well, Ka equals, actually, you can already manipulate it. H plus equals Ka times by acid divided by salt. Okay. So we know that the salt is this much, Kx, or actually let's just show Ka, H plus x minus over Hx, in this case Kx. So we can find out the moles of the weak acid, so let's do that. So moles of the weak acid Hx, so moles of Hx, just showing, clarifying to the examiner this is the thing we're trying to find the moles of, which is 100 divided by 1000 concentration time by volume. 0.05. 0.05. Okay, we've got that done. We've got that already in question. Then it's added 3.0 times by 10 to the power minus 4 moles of potassium hydroxide to the buffer solution. So what we need to do here is we need to subtract that value. So what we need to do is we need to because we've got these values, okay, so we've got the values of Hx, 0.05 mole, and now to find out the amount after we add potassium hydroxide, yeah, that's what we need to find. What we're going to do is we're going to do 0.05 minus 3 times by 10 to the power minus 4. The thing about this, what you can notice is, once you subtract 1 from the solution we add to the buffer solution, so in this case 3.0 times by 10 to the power minus 4 potassium hydroxide, the other thing we have the moles of, we add. So for the other thing, it's going to be 0.0136 plus 3 times by 10 to the power minus 4. So just the opposite. So what do we get? Well, 0.05 minus 3 times by 10 to the power minus 4. We get 0.0497. No 0.0136 plus 3 times by 10 to the power minus 4, 0.0139. Okay, and now we can find the pH. This is why I'm manipulating. At the beginning, H plus equals Ka times by acid divided by salt. Reason being is, now we found out the values. H plus is Ka, 1.41 times by 10 to the power of minus 5 times by the acid. Well, which one's the acid? Acid was the HX, the moles of HX, 0.05 minus this, so 0.0497. And therefore the other one that we have obviously is the salt. And what would this give us? Well, this will give us H plus. So once we put this in the calculator, 497 divided by 0.139, you get 5.04 times by 10 to the power minus 5. H plus equals 5.04 times by 10 to the power minus 5. Therefore pH equals minus log 10 H plus pH equals minus log 10 5.04 times by 10 to the power minus 5. And now I'm just going to put in the calculator. I'm just putting the value 2 decimal places, so then it's going to be 4.30. It's 4.297, so it's going to be 4.30. Okay. That was a very long question. So first things first, we rearrange it. Actually, first things first, we can find out the moles of the weak acid HX. Then find out then subtract by 3.00 times by 10 to the power minus 4. And then for the salt, 0.0136, add by 3.00 times by 10 to the power minus 4. And then we know H plus, we rearrange the equation from this to this. H plus is equal to Ka times by HX divided by X minus, or H plus is equal to Ka times by acid divided by salt. The acid is obviously going to be the weak acid HX, so 0.05 minus 3 times by 10 to the power minus 4, that is the acid A. And the salt is obviously this, 0.0136 plus 3 times by 10 to the power minus 4, 0.0139, that's salt. Substitute in the equation, so, and Ka already given us in question, 1.41 times by 10 to the power minus 5. We get concentration of H plus, and then use the equation pH equals minus log 10 H plus. Substitute H plus in, pH equals minus log 10, square brackets 5.04 times by 10 to the power minus 5. We get pH is 4.297, however it wants it to 2 decimal places, so therefore pH is 4.30. And the final question, 9.5, A buffer solution has a constant pH even when diluted. Use a mathematical expression to explain this. Constant pH even when diluted. Well, it's going to be ratio constant pH even when diluted. HX divided by X minus, and this is almost constant. But it wants a mathematical expression to explain this, so the mathematical expression is going to be hx over x minus. Hx over x minus. And that is with square brackets, obviously, and that is the end of question 9.